So now we'll basically start the electrostatics portion for class 12 physics. So the first thing to be learned in the electrostatics portion is basically the Coulomb's law. So what is the Coulomb's law? Let's state the Coulomb's law. So first I will read the Coulomb's law and then I will explain. So two stationary point charges Q1, Q2 repel or attract each other with a force F which is directly proportional to the product of the charges and is inversely proportional to the square of the distance r between them. So F is proportional to Q1 Q2 by r square, and this is basically the Coulomb's law. Now let us assume two charges Q1 and Q2 separated by distance r. So these two charges can either be both positive or both negative, or either one positive, one negative. So two stationary point charges Q1, Q2 repel or attract. If they are the like charges, then they will repel, and if they are the unlike charges, then they will attract each other with some force. That force is the Coulomb force. With some force called the Coulomb force, which is directly proportional to the multiplication of these two charges, to the product of these two charges, and is inversely proportional to the square of this distance, the separation between the two charges, the square of that separation. So F is proportional to Q1, Q2, F is inversely proportional to 1 by r square. Combining we get Q1, Q2 by r square. F is proportional to this. So we need a proportionality constant to equate this equation. So the Coulomb force F is equal to 1 by 4 pi epsilon naught Q1 Q2 by r square. So this is the proportionality constant 1 by 4 pi epsilon naught. But the value of this constant is 9 into 10 to the power 9 Newton meter square Coulomb inverse minus 2, where epsilon naught is the permittivity of free space. But the value of epsilon naught is 8.85 into 10 to the power minus 12 Coulomb square Newton inverse meter to the power minus 2. So this is basically the Coulomb's law, where these are the Greek letters. Okay. Now this Coulomb's law changes a little bit if a dielectric constant or dielectric media is present. So if a dielectric media is present of say a dielectric constant K, then a dielectric media always has a dielectric constant. So dielectric media is present with dielectric constant K, then Coulomb's law in dielectric media, this is not for dielectric media, for free space, and this is for dielectric medium. F is equal to 1 by 4 pi epsilon naught K Q1 Q2 by r square. So this epsilon naught K can be written as epsilon. So epsilon is equal to K epsilon naught. This is the permittivity of free space epsilon naught, this one, and this is the permittivity, this is the absolute permittivity. So it just decreases by a factor of K. So F is nothing but this one, except it decreases by a factor K when it is applied in dielectric medium. This Coulomb force is for dielectric medium. Now Coulomb's law holds good only for static point charges. As we have told earlier, two static point charges. So these two charges has to be static. They has to be fixed at a position in free space or dielectric medium. These two charge if moves or is in motion, that is they are dynamic, then Coulomb's law will not hold good. So it holds good only for static point charges. Now in vector form, this Coulomb's law, how it looks, let us see. So these two charges Q1 and Q2, this is 3D plane, where Q1 and Q2 charges have position vectors R1 and R2 measured with position vectors are measured with respect to origin. So position vectors of Q1 and Q2 are R1 and R2. So the vector joining these two charges, let it be R, and the unit vector along this is R cap. So this thing, this R is basically R2 minus R1 from triangle law. we know triangle of this plus this is equal to this. R1 plus R is equal to R2. From there, R is equal to R2 minus R1. So this R vector is basically R2 minus R1 vector mod square in vector form. So as this is a vector, this is a scalar quantity. So what it will, in the right hand side, what term will denote the vector? This R cap. This term has a direction along R. So this expression has a direction along R. So R cap. So 1 by 4 pi epsilon naught Q1 Q2 by R2 minus R1 mod square R cap. So this F vector acts along away from these charges. That is, if we are measuring the Coulomb force sitting on Q2 charge due to Q1, then it will act away from Q1 and vice versa. So F vector is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square R cap. So this R cap denotes that two like charges repel each other. That is, the Coulomb force is repulsive over here. As because of this R cap. This R cap denotes that the force is tending away from the, if we are sitting on one charge and measuring the Coulomb force due to other, it is away from that. So this is the repulsive force. This R cap denotes that. Where R cap is the unit vector along R. So now the electrostatic force or the Coulomb force. The electrostatic force or the Coulomb force is a central force. That is, it acts along the towards the center. Now R vector we have known R vector is equal to R cap. That is the position vector, that is unit vector, multiplied with its magnitude gives the vector. So R vector is R cap. So if we write R cap as R vector by R, then F becomes F vector, Coulomb force vector becomes 1 by 4 pi epsilon naught Q1 Q2 by RQ into R vector. So this is the Coulomb vector in another form, in another vector form. Now, what do you mean by conservation of charge? The total amount of charge in an isolated system, that is, it is not affected by any other charges from outside. The total amount of charge in an isolated system remains constant. That is, the charge can neither be created nor be destroyed, but only can be transferred. So if Q is the charge on a body, then it must be equal to an integral multiple of fundamental electronic charge E. So Q is equal to NE, where N is equal to 0, plus minus 1, plus minus 2, plus minus 3, these values. And E is the fundamental electronic charge of a proton, 1.6 into 10 to the power minus 19 Coulomb. So this condition gives the charge of a body is always constant. So what it tells, the total amount of charge of an isolated system remains conserved or constant. That is, it can neither be created nor be destroyed, can only be transferred. This charge is quantized, that is, the charge will occur at an integral multiple of the fundamental charge, this one, 1.6 into 10 to the power minus 19 Coulomb. That is, no fractional charges will occur, 2 by 3 E or 4 by 3 E, this type of charges, or 4 by 3 Coulomb E, 4 by 3 E, this type of charges will not occur. Charges will occur as 1E, 2E, 3, 4E, 6E, 10E, like this. So Q is equal to some multiples of E, integral multiples of E, any. So this is the quantization condition of a charge in a body, of a body. So 1 ampere, we'll read it later. When we'll do the magnetism part, we'll read the 1 ampere. For now, we are reading 1 Coulomb. So what is the definition of 1 Coulomb? 1 Coulomb is that charge which, when placed at a distance of 1 meter from an equal and similar charge in vacuum, repels it with a force of 9 into 10 to the power 9 Newton. So see this expression, Coulomb force in vector form. So what will be 1 Coulomb? So 1 Coulomb is that charge which, when placed, so 1 Coulomb means a charge has a value 1 Coulomb. So this is made say 1. Is that charge which, when placed at a distance of 1 meter, so this is also made 1. from an equal and similar charge. So equal means this charge is also Q2 is also 1 and equal to this, that is they are like charges. Hence they repel, in vacuum repels it with a force this, that is this whole thing becomes 1. This whole thing becomes 1. So we are left with this. What is the value of this? 9 into 10 to the power 9 Newton. So the only force we are getting is due to this part, which is 9 into 10 to the power 9 Newton. So the definition comes from this expression. You are making this 1 Coulomb. So it is placed at a distance of 1 meter from a similar and equal and similar charge. So it repels, and this is also 1 Coulomb. So the force acting between those charges, repulsive force acting between those charges is this one. That is 9 into 10 to the power 9 Newton. This is the definition of 1 Coulomb. What is the superposition principle? If a system contains a number of interacting charges, then the net force on any one charge equals the vector sum of the forces exerted on it by all other charges. We have a system of interacting charges, some charges. Then the net force on any one charge. So there is a charge, we are selecting one charge. Now the net force due to the whole system due on that charge is equal to the individual vector sum of all the charges, the forces exerted by all the charges on that charge. So this is basically the superposition principle, where a system contains a number of charges. The net force on one charge is equal to the vector sum of the forces exerted by all other charges on that charge in that system. So this is the superposition principle. That's all for Coulomb's law in electrostatics for class 12 physics. Thank you.